All right, so we're going to talk about solving a system graphically. And this isn't just any system, not the same type of systems we solved in Unit 1. These systems have one linear equation and one quadratic equation. Here it asks us to graph the system and list the number of real solutions. Notice that it doesn't ask us to find the solutions. It just asks us to list how many there are. So, this one, very easy to just do by hand. The line y equals x has a y-intercept at 0 and a slope of 1. So I can very easily plot the points and create that line. Likewise, y equals x squared minus 2 is a vertical shift down 2 of your parent parabola. So that should be easy to do by hand as well. So down 2. And then from there, we just use our parent pattern. So left and right 1, up 1. So that'd be here. And then left and right 2, up 4. 3, 4. There we go. Okay. And so when we look at this, again, we've graphed it like they asked, and then says list the number of real solutions. Remember that when you are talking about a system, the number of real solutions is the number of intersections. So in this case, it looks like they intersect here and here. So we would say that these have 2 real solutions. Notice that on B, the parabola is exactly the same. So I don't need to, do a lot of thinking again. I can graph those exact same points and draw that exact same parabola. My line, however, this time has changed to y equals 2x minus 3. So y-intercept of negative 3, which is down here, slope of 2, so up 2, right 1, up 2, right 1, up 2, right 1. And on this one, you'll see, because if I connected this blue is a little sloppy, but the red and the blue actually don't touch there. So this right here is the only intersection point, which means that in this case, what we're seeing is one real solution. All right, in C, y equals 3x minus 9 and our exact same parabola that we had before. So I can draw the same parabola that I had before. So moving our little dots, same places they were before. Now this line I can't plot with slope intercept because the y-intercept is off the graph. So here I would probably use the T-chart method. So for this guy, I would say if I want to pick maybe when x is 1, so I know 0 is too far down there, but when x is 1, 3 times 1 is 3, minus 9 is negative 6. When x is 2, 3 times 2 is 6, minus 9 is negative 3. 3 times 3 is 9, minus 9 is 0. So see, now I've gotten several points that I could plot. 1, negative 6 is just barely off the graph, but I can plot it if I want. 2, negative 3 would be here. And then 3, 0 would be here. So if I connect these, I would say that there are no intersections in this case. So we would say no real solutions. That doesn't mean that there aren't solutions. It means there aren't any real solutions. So they might be imaginary solutions there. All right, so this last one would not be as easy to graph by hand, just because looking at the numbers here, they'd require a lot more work. We'd have to definitely scale it differently. So we're going to use our graphing calculator to help us here. You will have instructions when you get to the test as to, obviously if it's on the non-graphing calculator part, then it'd be something that would be easy to graph by hand, like these first three. Something like this, you would be allowed to use your calculator. So go ahead and type these into your Y1 and your Y2 in your graphing calculator. As you can see, I've got them in here. Make sure also that if you've got your inequalities still from the last section, that you make sure to go over here and just change yourself so you're not on the super, the shading and whatnot. Okay, now my y-intercept here is 39, here it's 52. This parabola opens up, this line, because the slope is positive, slants up. So I'm not going to have a lot below the x-axis. So on my window, I'm going to, for right now, leave my x's as negative 10 to 10, because I'm not exactly sure what I'm going to need on that. My y's, I'm going to leave the bottom negative 10, but I'm going to make my y max 100. And I'm going to count by tens just because I want to see what I can see. Now, we may have to adjust again, but for now, I can see at least a good starting point. Okay, so from here, I can see, all right, here's my parabola. Here's my line. There are two intersection points in this case, and I would definitely kind of want a little more on the left side if I wanted to get a good picture. So I would maybe go from negative 20 to maybe 6, counting by twos. And the Y scale looked fine for being able to see everything that I needed. And there we go. Now, if you're expected to graph this on your paper like you see here, then you want to pick scales that are similar. So it looks like, because I'm counting by twos here, 2, 4, 6, it looks like my vertex is at about 7. And I'm counting by tens here, so maybe a little below 5. So when I go to do this, I'm going to say by tens, by twos, or label it on the graph. So 2, 4, 6, 7, and then about right here was where that vertex was. If I go back and look at it again, my line, 10, 20, 30, just below 40 because it was 39 there. My x-intercept on the line, negative 2, 4, 6, 8. So that helps me. So my parabola, 10, 20, 30, 40, 50, it crosses like right here. So it's going to go still off the graph some. But my line, of course, I already forgot, negative 8 is about the x-intercept. So 2, 4, 6, 8 would be right here. The y-intercept was just below 40, 10, 20, 30, 40. And then I can connect. And I can see the two intersections here, which means, whoa, getting crazy there. This has two real solutions. So wanted to make sure we reviewed how to graph that on the calculator as well. Okay, so now everybody's favorite part, we're going to do some word problems in this, and then we've got a separate video with more, just because it's going to be really important that you know how to set these up. This is going to be very similar to what you're going to see on the embedded assessment. So you definitely want to put a big star by this one because that'll help you with that embedded assessment. So the owner of Salon Ultra Blue is working with a pricing consultant to determine the best price to charge for a basic haircut. She must consider both supply and demand. The consultant figures that demand will be 350 haircuts minus 5 times the cost of the haircut. So, write a linear equation to represent demand. So, demand equals, and in this case, it says 350 haircuts minus 5 times the cost of the haircut, which is our x. Notice that in the next part, cost of the haircut is still my x variable. So this is my demand equation. It's a line. B, hairstylists are more likely to want to work at the salon if they make more money. The table at right describes the supply of haircuts stylists are willing to provide based on various prices per haircut. Write a quadratic equation to model the supply, round to the nearest tenth. This right here is the key that tells you I should use my graphing calculator because it tells you to round. So we're actually going to do the exact same thing that we did in the regression lesson. We are going to enter this data and we are going to run a quadratic regression on it. So I can get rid of the stuff from last video and go in. Remember that we entered data in stat choice 1 for edit. I've got stuff in my list 1, so I'm going to scroll up to where L1 is highlighted, and I'm going to press clear, not delete. Don't press delete. If you ever do that, take it to your teacher to fix it, because that's a problem. So X data 20, 30, 40, 50. So we're going to enter that in our L1. So 20, 30, 40, 50. Then I'm going to scroll over to L2 and I'm going to input that data. So we've got 1555. So 1555. Then I think it was 115. And the last one is 195. All right, so I've got my data in there. So now I can quit out of my list and I'm going to stat calculate. If you've forgotten how to do all this, go back to your linear regression notes. All the steps are typed out. We're going to choose choice 5 for quadratic regression. My X list is in L1. My Y list is in L2. The most important part, don't forget, store regression equation. If you have a newer calculator, you can press alpha trace and choose your guy here. If you do not have that, then you'll need to press vars. Go to yvars, choose function, and then select it from there. So 2 ways to do that. Scroll down to calculate, and it's going to spit out my quadratic answer for me. So y equals 0.1x squared plus or minus x minus 5. Remember, we don't care about the r squared part. So I'm going to go ahead and write this out. Y equals 0.1 x squared minus x minus 5. I have rounded to the nearest tenth. This is the supply. Now it wants me to solve the system of equations with my graphing calculator. So I go back to my y equals screen. Notice that it has already typed in my quadratic regression equation for me. So now I just need to press in my linear equation, 350 minus 5x. I have no idea what type of window I'm going to need exactly, but I do know that my y-intercept is 350 on this guy. So I'm going to maybe go from negative, well, price is not going to be negative, so I'm going to do -5 to 100. We're talking about price of haircuts, and the data in there went up to 40, so I'm going to go up to 100 here. I'm going to count by 5s. Then since my y-intercept's 350, I'm going to maybe make that y max 400, and I'm going to count by 40s, and we'll just see how that looks. All right, So I can't see the entire parabola, but in this case, that's really not entirely important because what we're trying to do is find where supply and demand intersect, because that's going to be your optimal price, because that's going to make you the most amount of money. So all we need is to be able to see the intersection, which I can. So go to second trace, choice 5 for intersect. Yes, this blue guy is my first equation. Yes, that red one is my second. And yes, I want the calculator to guess. And now it gives you your solution. Now, the actual solution in this case is 42.85 and then 135.75. Now, since it says solve the system, I suppose I probably should go back and find the other intersection point, which is going to be on the negative side. So I'm going to go to negative 100 here for a second to see if I can see it. Because when it just strictly asks you to solve the system and it's not asking for anything else, then that means that it usually wants the other one. And you can see it's way up higher than 400. So I'm going to change my Y max to 1,000 and counting by hundreds and see if I can see the other intersection at this point. I can, hooray. So I need to find that other intersection point. So second, trace, intersect, and I need to move. Remember that if you don't move your little cursor close to it, it's just going to find the other intersection again. So enter, 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 negative 82.85. So negative 82.85. And our Y is 764.25. 764.25. Okay, now this is a good thing that happened, because if it just asks you to solve, it wants both the answers. It's this part where we're going to say, hey, this doesn't make any sense, because we're not going to charge a negative amount for a haircut. You don't walk into a salon and have the hairstylist say that they'll pay you about $83 to cut your hair. That's not going to happen. So our first interpretation is when the price is 42.85, the salon's demand and supply will be equal at about 136 haircuts. And then you do need to say the other solution doesn't make sense because the price won't be negative. There are some situations where negatives do make sense, because sometimes even with money, if you're taking a loss, that would make sense, but this is not one of those cases. No salon is going to pay you to cut your hair. So it doesn't make sense. We've interpreted. Notice it said solutions. We interpreted both of them, so we're good to go.